Is there anybody here? Is there anybody here? Is there anybody? Is there anybody? Is there anybody here? And now I lost Kyle. And there's Kyle. So I have no idea if I just completely biffed this now that we're 10 minutes in. Maybe other people came and wandered away or what. And I also don't know why my calendar, the links on my calendar are different than the links on Canvas. That's very strange. Well, okay. So sorry about that. That was confusing, and I may have made a bit of a hash of things tonight, but here we are. Do you have any questions?
Yes, I do. It's related to the next homework assignment. That's
okay.
Friday.
Yep.
I'm going to look it up in the book quick. A few students, Cole, Natasha, Richard, and I were working on exercise 9.17 last night. And we had, we ran into a few complications with the proof. We tried going with the consequent, but we just couldn't get anywhere. We were confused on how to deal with the negations.
So, just a sec, let me get my book too, and my list of theorems. So which problem are you talking about?
Exercise 9.7, or 9.17, I mean, sorry.
Okay, 9.17, yeah, I'm with you. And you tried doing what? And what bad thing happened?
We started with, we tried doing the right side.
Yeah.
We translated the right side starting with proof. I believe we started with 9.17, generalized De Morgan.
Okay.
So that introduced for all and the negation. But we weren't sure how to move on from that. We tried doing translating that further, but we just couldn't get to a point where it was evident how we could solve the proof.
Right, I'm with you. So, if you were distributivity, I think what you want to shoot for here is to try to get to distributivity of and over for all, which is 9.7. So let me pull up the tablet and and share a whiteboard, and we can look at what that might mean. Oh, come on, really? Are you going to do this to me? Oh, there we go. That's better. So we're trying to prove, so the goal, oh, no, stop it. Sorry. So the goal that you're trying to prove is distributivity of and over equivalence, which says P and, or not equivalence, P or over exists, P over P and exists X are Q, equivalence exists X are P and Q, provided X doesn't appear in P. So that's what we're trying to prove in that exercise, right?
Right.
Okay. Now, if we look at 9 points, so that, and this is trying to prove 9.21. If we look at theorem 9.7, it says, whoa, hang on. Oh, hold it. Am I doing the right problem? You're talking about exercise 917?
Mm-hmm.
Oh.
But that's we have to solve for 9.21 though.
Yes, right. So that's theorem 9.21.
Mm-hmm.
And okay, so when I said 9.7, I'm up a tree. That is not what we want. Undo. We want 9.5. There we go. I had the wrong distribution rule. So, oh, stop that. You great flaming weasel. Okay. Oh, and now, doink. Boom. We'll get there. 9.5 looks like P or for all X R Q equivalence for all X R P or Q, right? And I got all this correct. Oh, no, I didn't. I made a boo-boo here. That's good because this would have never worked otherwise. That needs to be an and. And that's pretty critical. So in 9.21, that's an and. Yeah, okay. Now, so I think that if you said you started with the right-hand side?
Correct.
And then you use generalized De Morgan's on it, right?
Yeah.
So that should have given you a for all here and a negated P and Q, which should turn into a not P or not Q with regular De Morgan, in which case you then match this side of 9.5, write that over to the left-hand side of 9.5. You'll need to then use regular De Morgan to turn this or into an and generalized De Morgan to turn the for all back into an exists. But if you do those two things, you should be able to come back to this side here.
Okay.
Does that make any sense? And does it sound at all like what you guys tried to do?
No, I'm not sure what we were thinking exactly, because hearing this, if I had saved my work for it,
that would have helped.
Yeah, that would have helped. Yeah. We went after spending a lot of time on it. We decided to go on to the translation problems.
Okay.
So
So
I
now it shouldn't be that long a proof. Like it really should be basically generalized De Morgan, regular De Morgan, 9.5, regular De Morgan, and generalized De Morgan, and you're back where you start. You're back to the other side. I mean, I think that's basically the structure of the proof.
looking at it, it makes sense.
Right. Cool. So, other questions? Or was that the main thing?
That was the main thing I had for now.
All right. Does Fearless have any questions?
Oh, hi. I didn't know we had Dojo today. I thought it would be like on Slack, like chat.
Well, I mean, my idea was that I would continue to do this, but I mean, given that I think you two were the only two that came last week,
Yeah.
and you're the only two that are here this week. I don't know. This might not be the best use of everybody's time. But since you're here, I'm happy to answer questions.
Okay.
I may cancel this moving forward, but you're here now. So if you got questions, I'm happy to for either
I
one
was
of
just
you.
surprised. I thought when you sent me the message on Slack, I just immediately joined. Okay. I have questions about chapter 8.
Yeah.
So on the last problem set, like typically chapter 8, I'm not sure how to use it. Like the stuff, like the chapter 8 rules with other stuff.
So I think chapter 8's a weird chapter, and people are often confused about how to use it because most of the rules in chapter 8, it's a big set of axioms, and there are these super general things, and then we can't do anything with them in chapter 8, but then we use them when we get to chapter 9. So there's a lot of these things like the distributivity rule and the 3 range split rules and the nesting rules and that kind of stuff we don't really we don't do anything with them until later, which makes chapter 8 kind of a weird chapter. It's like, here's a set of important facts. You can't use them yet. We're going to move on now. And then they turn out to be useful later on. But you have to kind of remember that they were there.
Yeah.
So I don't know, is that the kind of problem that you're having, or?
I was talking about like exercises from chapter 8.
Oh, so like the split off term?
Yeah, and stuff like that.
Well,
Like
I mean,
the last
really,
problem set, not the one we had 2 days ago, like the one before.
right. I mean, all there was from chapter 8 on the problem set were the type problems and the split off term proofs, right? I think that's all
Yeah,
there was.
like the proof the following theorems, provided 0 is less than or equal to n, like stuff like this.
So like, can you give me a specific problem?
Okay. Let's say chapter 8, 8.5 or 6 or 7, like stuff like this.
Yeah, right. So these are all just split off term problems, except for 8.7. 8.7 is a little different. But
Yeah.
8.5 and 8.6 are just split off term problems.
Mm-hmm.
So would it be useful to do one of those? I'm trying to figure out what would be helpful.
Yeah. Maybe 8.6, something from 8.6.
Sure, we can do that. You want to pick one? I don't care.
I don't know. Maybe C or D.
Does Kyle care between C or D?
Um, no, I don't have any preference.
Okay. Well, let's do C just for fun.
Okay.
So we are supposed to prove or I 0 at most I less than n plus 1 bi equals 0 equivals b of 0 equals 0 or I, and I just moved down to another line because otherwise it was going to get really long. 0 less than I less than n plus 1 b I equals 0. So that's what we're trying to prove. Are we with me there?
Yeah.
Okay. And if we look at the two split off term rules, the second one looks to be the more promising option. And it says, so this is 8.23, and it says P, oh, sorry, star I 0 at most, I less than n plus 1, P equals P with I replaced by 0, star star I 0 less than, oops, not less than or equal to, less than I less than n plus 1 colon P. Doink.
Mhm.
Okay.
And then there's the star PIN thing
Uh,
at the end.
no, that's version A. We're doing version B, where
Oh,
the
the
P
book
with I
has one.
replaced by 0 is on the left-hand side.
Oh,
There's the two versions. You got to make sure you use the right version for the problem you're working on.
like is
And
it A and B? Because my book just shows one.
you're looking in the back.
Yeah,
Yeah, in the back, they only give one. If you look in the chapter, there are two.
that's weird.
Yeah, and I've mentioned that a couple of times.
Yeah,
It
yeah.
confuses people all the time because people are just looking in the back, and normally the back is totally helpful. And then in this one instance, the back only gives you one of them, which is kind of strange.
Yeah.
So this part is going to match up here. This is going to match that. This is going to match all of this. And this part is going to match this.
Mm-hmm.
And in fact, everything matches up really nicely. Star
Yeah.
is just or everywhere. Star, star. I less than or equal, 0 less than or equal I less than n plus 1 matches perfectly. P needs to be P needs to be bi equals 0, so that needs to be P. And that works because this turns out to be P with I replaced by 0, so that's good. So if P is this, if you replace I by 0, you get B0 equals 0. The rest of this all matches, and so this is done, actually, basically by 9.23. You could be like, Um, if you
9.23.
write the whole thing, you could just say basically done by 8.23b with P gets BI equals 0. Boom. And you could just be finished with that. Or you could start with one side and say it rewrites to the other side using 8.23b and that substitution. But that's really all you have to do.
Oh, yeah, that's not that bad.
No, and that's true for all of 8.5 and 8.6. I mean, they're really that simple.
Yeah, because with 8.7 it was different.
Yes, 8.7 is different. That's a harder problem.
Yeah. I'm not gonna ask you about it because it's on the problem set.
But you could ask about it. I mean, I could give you a hint.
Okay, I did the problem set. I sent you something on Slack, like if you want to.
Yeah, I saw that.
Yeah.
And so, I mean, I'm happy to give you a hint if you want to like continue to work on it. What?
That would be nice.
Yeah. So, so let's see if I make a new page and I say, okay, so now we're talking about exercise 8.7. And here our goal is to prove that the sum over I, 0 at most I, less than n I equals the sum over I, 0 at most I, less than n, and even I plus
the odd.
The sum of I, 0 at most I, less than n, and odd I. Okay.
Mm-hmm.
So now first, it's probably worth making sure we sort of get what's going on here. So if we imagine taking all of the integers and we divide them up into two groups, there's the evens. Oh, let's make this match.
Yeah, everything is gonna add up to the full number to everything at the end, I guess.
What?
I guess if you add the evens and the odds, it will make everything.
Yeah. So if you have the evens and the odds, and then you have like as a subset, you have 0 at most I less than n. Some of those are going to be even and some of those are going to be odd. Everything will be one or the other, and nothing will be both, right?
Yeah. So
it splits up into two disjoint sets. Everybody's in one of them, nobody's in both. And that's really critical. So if I were to have let's just, to simplify things, let's imagine that I have P and, oh, I didn't want red there. Doink, doink, doink. Oh. Let's imagine I've got P and, P of I and even I. Or P of I and odd I. Okay. So let's just imagine we've got something that looks like that. Now, I could, if I wanted to sort of rewrite this, one thing I could do is I could pull out the P of I.
Yeah, or odd I.
Yeah. Right. And now even I or odd I is, what is this going to be?
What do you mean?
Well, what can you simplify it?
No.
I
I'm not
think you
sure.
can.
Oh, with the
Using what you know about just even and odd. I mean, we're talking about stuff from, that you learned years ago. If I say I is even or I is odd,
oh, it's false. Okay.
no, I is even or I is odd,
So it's either even or odd.
right? So that means that this is always what?
Oh, true.
Yep, bingo.
Okay.
So let's see. This was 3, 4, 6. Just so I got the numbers in. So this is true by arithmetic,
Okay.
and then this is just P of I by identity of and 339. So that's the central observation. You've got to to do the problem, you have to do some chapter 8 stuff to join these two.
Yeah, there's a hint. I think I forgot. Says like use some. It was 8.16, I think, or something.
That sounds plausible. Let me look. I don't remember. No, not. Oh, yes. Yeah, 8.16. Notice that you have to show that R and S is false to be able to use 8.16.
Yeah, which is what's confusing me because I don't understand what that means.
It means that, well, this is R,
Mm-hmm.
this is S.
Mhm.
So you have to show this and that is false. In the same way we showed R or S is P of I, you have to show R and S is false. So it'd
And
be another calculation very similar to the one we just did.
And that's just how the question is solved. Like you just need to show that R and S is false, and that's it.
No. You need to show R and S is false to be able to use 8.16. You can't even use 8.16 if you haven't shown R and S is false first.
Okay.
Once you've done that, then you can use 8.16 to rewrite the right-hand side in a useful way. And then all of this calculation that's in blue will start to matter.
Okay. Yeah, I guess.
You do not have the convinced sound.
I'm convinced. I'm just thinking of how.
Okay.
Like I'm doing it in my mind while we're talking somehow. Trying.
Yeah.
Yeah. Yeah. These are my questions for now.
Okay.
Does Kyle have any questions?
Kyle, got anything?
I don't have a question about concept, but
Sure.
could we go over an exercise for translating English statements to
Yeah, totally.
Oh, just before you start, on the midterm exam thing on Canvas, it says chapters 1 to 3 and then 5 to 12, I think.
So I actually edited that maybe 2 hours ago and removed the 12 part.
Okay, how about chapter 4?
4 should have been there. Did I leave 4 out?
Yeah.
Really?
I think so.
I'm a doofus. Let's see. Yeah, you're totally right. Weird. How did I leave that out? I'll fix that. Yeah, okay. It totally plus chapters, so it should have been 4, 5, 8, and 9. So I've now updated that. So if you reload the page, it should include 4 now.
Okay.
So that was just, I don't know, I was dumb. Okay, so Kyle, what would you like to talk about?
Okay. Could we do Exercise 9.29 F, if that's not on the homework.
I'd have to look. I don't honestly remember what's on the homework. Let me have a check. Go away, assignments. I never remember what's on these big assignments. So this is chapter 9, part B. 9.29, we assigned A, G, and K. So F is fair game.
Awesome.
So exercise. Oh, let's go to black. Exercise 9.29 F. Is that the one you wanted?
Yes.
F. So the statement is cubes of integers are never even, which is a false statement, by the way, but that's not here, neither here nor there. Okay, so first thing, is this a statement about all integers or some integers or what?
If my I guess what I'm thinking would be for all.
Yeah, I think when it says cubes of integers, it really is saying all integers, right? Because it's not saying cubes of 7 or cubes of odd integers or cubes of integers greater than 20. Like it's really saying everybody. So I think this is for all I in Z. And it says cubes are never even. So as a simple solution, we could say just not even I cubed, right? Now, we can't really say that because they tell us we have to not use even. But as a simple start, we could be like, for all I cubed is not even, is a way of saying cubes of integers are never even. Does that make sense?
Yep.
Is that the answer?
No, it's almost the answer, but it's not quite because we've got this even and they tell us we can't use that.
So we just use arithmetic and make it into odd? Is that one way or?
Oh,
no?
So you could decide to make that into odd, but what I would, but you're not allowed to use odd either. So that doesn't really solve the problem. What you really need to do is replace even with that thing that we looked at earlier in class, where we're like, what does it mean for something to be even? It's even if there is a j in the integers such that I cubed is 2 times j. So this becomes this.
Can you explain the 2j part?
So what does it mean to be even? A number is even if it is equal to 2 times something. And so we say that by saying there is a j where I cubed is 2 times j.
Okay.
So if you say 24 is even, I'm like, well, okay, why? And you say, because it's 2 times 12. And if you say -8 is even, I'm like, well, prove it. And you're like, it's 2 times -4.
Okay, I've never thought of that.
Yeah. So to say something's even, we just say there exists a j such that I cubed equals 2j. And we say something's odd by saying there exists a j where the thing is 2j plus 1.
Well, if it was odd, not odd, never odd, how do I display that j?
So then if to say something's odd,
I mean, are never odd, like in this.
Well, I mean, that's just a negation at the beginning of the thing, right? The negation just sort of carries along. The important part is the odd part.
Yeah.
And that is x is 2j plus 1.
Oh, +1. Yeah.
Yeah.
Okay. Okay. How about -1? Or no, that doesn't work.
-1 would work fine.
Okay.
In fact, adding any odd value, positive or negative, you could be like 2j plus 17 or 2j minus 101. Those would all work. They're just, people tend to use +1 because it's easiest to think about.
Yeah. Okay. Okay. Makes sense. Oh yeah. That.
Did that make sense, Kyle?
Yeah.
Was there a problem like this where you were stuck, or were you just like looking to see another example, or?
I was just looking to see another example.
Cool.
Can I have a quick question? Ask a quick question.
Yeah.
I do not. So in 9.17, it's on the assignment. But what does provided x does not occur free in P? What does that mean?
It means x doesn't appear in P. P is some expression, and P could be a lot of different things. And we're saying we're going to assume that if it's true that x doesn't appear in P, then you're allowed to use 9.21. But if it does appear in P, you don't get to use theorem.
So do we use assumption, or do we have to prove that x does not occur in P?
No, you assume it.
Okay.
You assume it, and then you prove the theorem using that assumption.
Okay.
And
So
you'll
it's like
need that because one of the theorems you'll use to prove 9.21 also requires that x not appear in P. And so you'll be able to satisfy that requirement by saying, we assumed it. Huzzah!
Okay. One more question. What does in 9.19 like not occurs mean? I forgot.
Same thing. That's just a shorthand for provided x does not occur free in P.
Okay. Are these Dojo classes gonna be like uploaded or not?
Yeah, I recorded and uploaded the last one. I'll record. I am recording, and I will upload this one.
Because I couldn't find the last one.
Did I never post the link?
I don't think so.
Let me look. I think you are correct. I think I did not ever post the video from the dojo last week. I meant to, and I just didn't get it done.
Yeah.
So my bad. I will try to post last week's dojo and this week's dojo later tonight or tomorrow morning.
Okay.
Sorry about that.
No, it's okay. Chapter 8. I have one more question.
Yes.
Okay, it's about chapter 9. Okay, so from the the rules and axioms and stuff in the last pages and last page, where was it? Oh, are we gonna take 9.30 or no, or not?
What axiom or theorem 9.30? What are we talking about?
Yeah.
So let me find 9.30 and then I'll tell you. Yeah, we talked about that in class yesterday.
Oh, I haven't watched the thing yet.
Yeah, I talked about that for, 10 minutes yesterday in class.
Okay, then I'll watch it.
And to give you a heads up, the short version is we will use it later, but we won't use it right away. But it'll turn out to be really important when we get to chapter 12.
Yeah.
But we don't use it very much
In this
right
chapter.
now.
Okay, so okay, that's good. Oh yeah, I have one more question if Kyle doesn't have any.
Is Kyle good?
Escalate.
Okay, go for it, Fierce.
Okay. It's about the previous problem set. Again, just a hint because, you know, it was, the question that, let me check, was not, I have the book open on my laptop. What am I doing? It was, okay. It was the one where you suggested using shunting. I can't find it. Hold on. I'll open Canvas on my phone because for some reason it doesn't show on the laptop.
I assume exercise 9.9, maybe?
Yeah, 9.9.
Is that your, well, it could also be exercise 9.5, both of them.
Oh, I can check on
Shunting.
Canvas real quick. It was 9.9.
Okay.
So how do you use shunting in this in the first step? Like, that confused me.
Well, let's open up a new screen. So exercise 9.9, which is theorem 9.12. So the theorem says for all x r, q implies r, implies for all x
RQ
rq
implies
for all x r, whoa. Oh, this should have been a P back here.
oh no, it's correct.
No, this should have been a P.
Oh yeah.
So let me,
I mean, I see the shunting part, but how do I use it? Like, I see the errors and stuff, but I think
so
yeah.
you can rewrite this as for all x r, so this is shunting. Q implies P, and for all x r q implies for all x r p. So shunting lets you do that. Does that make sense?
So shunting is 3.65. I'd assume we have the right side of shunting.
No, this is all, hang on. I'm about to say something and not know what I'm talking about. Let me back up. So I don't lie. Yes, this is the right-hand side of shunting. You're correct about that.
So we're gonna make it into the left side.
Correct.
Okay.
So all of this is P,
but
all of this is Q, and
well,
all of this is R.
yeah, but then like the Q and R are all in one bracket, in one parenthesis.
Correct.
So,
and they are both in the problem and in 365. There's a pair of parentheses here and here that hold them together in what we're proving. And there's that same pair of parentheses in 365.
Okay. Yeah. Okay, makes sense.
Does that make sense?
Yeah, and then I'd assume you need to find, like, make it into true, all of it.
Well, actually, I just started with the left-hand side.
Mm-hmm.
So, you know, I would say then for all x, r, Q implies P, and for all X, R, Q. And then that was blah, 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 blah. And eventually
With just RP.
get just
Oh,
RP.
I didn't think that this is okay. I didn't think that this was possible. Does that prove that it's true if you do this?
It proves that this implies that, which is
Oh,
what we're trying to do, is prove that this implies that.
if I thought of it this way, maybe my result would have been different. Because what I did is used shunting, and I think was 9 point. What was it? I think I used De Morgan's or something. No, never mind. I used something, and 9 and shunting at the same time somehow. No, yeah,
Well, it doesn't sound good. No, I would use shunt, and you could take the whole thing and show that it's equivalent to true if you
yeah. It's
prefer.
just yes.
It's just, how you write it. But this way you don't have to write this right-hand side over and over and over again.
Yeah.
So yeah, if you start with this and then you do a chapter 8 rule actually first, then that'll like bring you into one quantifier. You do some manipulation, use another chapter 8 rule to split it back into 2 quantifiers, and then weakening and strengthening wraps up the end and you're done.
Oh, okay. Well, thank you.
No problem.
And that's all for 3 points. Wow.
Yeah, I mean, it's always tricky. Like, do you make the hard problems worth a lot more? And then
Yeah.
if people don't get them, they really tank?
Yeah, I
Or
know.
do you make the hard problems worth the same amount? And then if it's not really consistent with how difficult they are, but it means it hurts less if you just don't see a way through it.
Yeah.
And I've tended to go for just make everything worth the same amount. You could argue
Yeah.
that, but it's a choice.
No, I just thought it was super easy. That's why.
No.
Yeah.
Definitely not super easy.
Yeah. Okay. Oh, just one last tiny question. So let's say this RP stuff we have on top of the then, can I like substitute P with like false or true, or is that okay?
Where do you want to do that?
Under shunting, let's say the P's, can I just substitute all of them with a false or something using like some axiom?
So are you trying to do it in this shunting step here, or is this a more general question about shunting?
More of a general question, like can you substitute stuff like the P's for like falses or trues or something?
If you need to make it match, right?
Yeah,
I mean,
but then you have to switch all of them.
Right. So 3-6, as an example, 365 says P implies Q implies R equivals P and Q implies R.
Yeah.
Okay. Now, because this is true, it's true with any substitution. So it's totally fine for me to say, P implies Q implies R. Oops, sorry, didn't mean to have that last one there. Boink. Equivals P and Q implies R. With the substitution, I don't know, P gets false. That would be false implies Q implies R. Equivals false. Oops, false.
Then
and Q implies R.
And then I can substitute.
A legal substitution. This is now a true thing.
I mean, can I use this in the top part, like in the all X R Q implies P? Like,
No, probably not. I mean, if they were not already, I mean, if you're trying to prove something and it's got P, Q, and R, you can't just replace those with true and false. That'd be like, we're going to try to prove something for all X, and you're like, I'll prove it for 5, and then I'm done. It's like, no, that doesn't work because 5 isn't all numbers. If you have a true here for Q, for example, or a false for P, right, you could use a substitution like this to get something in your statement to match another theorem.
Okay.
But you can't just like be substituting in the thing you're trying to prove. You can only substitute in the theorems or axioms that you're using to get them to match the thing you're trying to prove.
Yeah, makes sense. Okay, because I did what I did. Oh, I just asked you, and yeah, that's bad.
Yeah, that doesn't work.
That's a disaster. Yeah. Yeah, that's all my questions.
Cool. So I'm going to go get dinner. Kyle, do you have anything else, or are we good?
It's just one technical thing.
Yeah.
When we're I'm translating the predicate statements or the statements of the predicate logic.
Yeah.
Is it necessary to put a QED after it?
No, because you're not really proving anything. QED is, and it's never necessary to say QED. I mean, that's just a habit, a way of saying I'm done. QED would technically be something you would only do if you were proving a theorem. Then you would say QED is a way of saying I have successfully proven the theorem. I have demonstrated what was supposed to be demonstrated.
Okay.
A translation doesn't really have that form, so I probably wouldn't say QED at the end of a translation.
All right.
Does that make sense?
Yep.
Coolio. Okay, I'm gonna go get dinner. I will talk to you fine people later.
Yep. Good night.
Ciao.